Oh, sorry. Oh, I don't know what happened. Okay. It's late, kids. It's 12:05 at night. You know me. I'm a morning person, but I know you want these answers up. So here we go. This is Mr. Key. This is still part 1. This will now be problems 13 through 24. Eventually, all of these videos will be found at www.N stands for Newman, K stands for Krause, that would be me, infinity.com. Infinity stands for the length of a math class. Or if you're a math person, then maybe a social studies class. Okay, I don't know what page we're on. Let's say 5. Hey, I got it. Page 5. So here we go. The height of a rocket at selected times is shown in the table below. Based on this data, which is not a valid conclusion. The rocket was launched from a height of 180 feet. So at time 0, it was at 180 feet. So that is true. Again, we are looking for something that is not true. The maximum height of the rocket occurred 3 seconds after the launch. That appears to be true. That appears to be true. Don't know for sure then. Let's just check. The rocket was in the air approximately 6 seconds. So at 0, 180. And after 6 seconds, it was still 180 feet in the air. After 7 seconds, it was 68. So that's not true. Oh, which is not. Oh, this looks like this might be our answer. It looked like 2 was correct. And the rocket was above 300 feet for probably 2 seconds. So from here to here, for about 2 seconds, it was above 300 feet. So approximately 2 seconds. That makes sense. So choice 13, I would say, is question is choice 3. Let's see. Yeah, got it right. A parking garage charges a base rate of $3.50 for up to 2 hours. And then an hourly rate for each additional charge. So I got to figure out which one of these equations will give me my hourly rate. Well, I'm just going to figure out what my hourly rate is. So I know this is just basic, 2 hours. But if I'm going to go to here for that 1 extra hour, isn't that adding $5.50? And if I add $5.50, so my hourly rate is $5.50. So really what they're asking for is which one of these equations, when I solve it, is going to give me $5.50. So let's try these. The first one, I've got 3x. Now I'm going to bring the 9 over. So subtract 9 is equal to 11. And I divide by 3. Clearly that's not going to give me 550. So that ain't it. I'm going to subtract 9, do the same thing. Now I get $3.50 is equal to 11, 350 cents x. So maybe that's right. So I'll take 11 and I'll divide by 3.5. I hope that's 15 or 5.5. Not even close. Now that ain't going to work. Let's try this one. Let's subtract 350. So I get 2x equals 14 minus, that's 11. Oh, divide by 2, and I get x equals 550. And that's your answer right there. There she is. Weird question, though. I'm not going to lie. That's a weird question. So, may not have started to think that way, but that's how you do it. Okay, kiddies, let's keep going. Here we go. Oh, my gosh, what the heck? Where'd we go? 6. There we go. Man, that's weird. Okay, so what I have here is which one has a constant rate of change. Again, rate of change is just slope. So which one has a constant rate of change that is -3? Let's check this one. This is the easiest one to do. Down 1, 2, 3 over 1. Nope. That's down 4 over 2, or down 2 over 1. So this is a slope of -2. So that ain't it. Let's see. Up 3, up 3, up 3. That's got a +3 rate of change. That ain't it. Let's see. This went down 3. and then down 7, and then up, nope. And if I divide by 2 here, divide by 2 here, you'll notice my slope is -3. And again, slope is rate of change. So that's number 15. We're almost done. Kendall bought X boxes of cookies. Oh, I'm so hungry, to bring to a party. Each box contains 12 cookies. So how many cookies are there, just for fun? There are 12 X cookies. She decides to keep 2 boxes for herself. Little Kendall's a little piggy. She should share. But whatever. I would eat 2 too. So I'm a big piggy. She brings 60 cookies to the party. Which equation can be used to find the number of boxes Kendall brought? She decides to keep 2 boxes. So we don't know how many boxes she has, but there's 12 cookies. So she didn't bring X cookies, X boxes of cookies. She brought X minus 2 boxes of cookies. So we know the total number of cookies is 60. So that's why 60 is on the right. So we're going to take 12, and we're not going to multiply by X. We're going to multiply by X getting rid of 2 boxes for the biggie, for me. So at 12 times how many boxes she's going to bring. She was going to bring X, but now she's going to bring 2 less, X minus 2. And if I multiply those, that should tell me how many cookies I have. Well, this is just 12X minus 24 equals 60. Should be choice 3 for number 16. Oh my gosh, another one down. The table below shows the temperature, T of M, of a cup of hot chocolate that is allowed to chill over several minutes. Which expression best fits this data? Probably the best thing I can do is just do regression on it. Now, you may not know it, but look at these equations. They all look like exponential regression because they all have a base and an exponent. So let's take a look. I'm going to do exponential regression. So let's go here. Let's go here. See how there's something there? Get rid of that? No. We got time and temp. So time and, or maybe time. It's late. Temp. All right. Time and temperature. 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. 150, 108, 150, 108, 78, 56, and 41. Now, before I do this, let's talk about which 2 don't make any sense, just so you know. These 2 will not be the right answer. Now, the reason these 2 will not be the right answer is because this is going down. It is decaying. If you have something bigger than 1, that's exponential growth. I want exponential decay. Now, if I'm a betting man, I'm going to probably guess it's choice 1. But let's just check. It's exponential. It's exponential decay, so we'll go into menu, statistics, stat calculations, and exponential regression. Choose. What do we call that? Was it time? Yeah, time and temp. I don't know why I got all that other stuff. And I go over here, and there's my equation, 150 and 0.85, but 155 to the x, and there it is, choice M. Now, how could I check that another way? Another way I can check that is to say, okay, let's graph. Let me get rid of that doc B, go back into graph mode, and I'm going to just type it in, 150, parenthesis, 0.85, parenthesis, to the M. In this case, you have to write to the X. Now, there's my equation. Ooh, doesn't that look fancy? It's not even there. So I go Control T. That's really what I want to look at. Is 0, 150? Yep. Is 2, 108? Yep. Is 4, 78? Yep. Is 6, 56. Yep. Do you see how I'm doing that? I just go down to the table. 8 is 41, and 8 is 41. Now, it's not exactly. That's because we rounded. All right. There's a couple more problems done. All right. Let's keep moving. I'm just checking to see if the first one's up. Is the first one up? Yes, the first one is up. I'll get that to you in just a second. Okay. As x increases beyond 25, which function will have the largest value? What? As x increases past 25, which will have the largest value? 18 is definitely 1. Now, how are you supposed to know that? Well, here's the thing. You could just graph all of these. Doc B. What you really are supposed to remember is that exponential growth have the biggest changes. And because this is an exponential function, it's why it's the right answer. But let's just check it. 1.5 raised to the x. Enter. Boom. Then we're going to go 1.5x plus 3. So tab 1.5x plus 3. Wow. Then we're going to go 1.5x squared. Tab 1.5x squared. Now the blue ones you're going to look at is going to look like the least steepest. But remember, it's exponential. So we got one more to do. Tab 0.5x cubed plus 1.5x squared. Now this one's going to be really steep. Now if I move this over here, if I keep moving this, now it looks as if the blue function is nowhere to be found. Actually, the blue one finally passes the red one here, but the black one and the purple one is the steepest. But remember, it wants it at 25, so I got to grab my handle here, and I got to go, how do I do that? Anyway, I'm going to go to the table, Control T, and I'm going to look at 25. And I want to see who's got the biggest number at 25. Maybe even 26. It says after 25. So the exponential function, which is 1, is 37,876. The red function is 42. The purple function, or the linear function is, the quadratic function is 1,014, and the cubic function is 9,008. So clearly at 25, the first function is the biggest. And exponential functions grow really, really, really fast. Hopefully your teacher did like a penny thing and said, hey, if it's exponential, that's the fastest growing thing there is. All right, what are the solutions? All right, let's just grab 3x. We're just going to factor this. Plus 10x minus 8 equals 0. I factor by guess and check. I don't know how your teacher does it. So it's going to be 3x and x. I got to put a 4 and a 2 in there somewhere. And I'm going to guess the 4 goes here and the 2 goes here, minus and plus. This gives me positive 12 and negative 2. So my two answers are going to be x equals 2/3 and x equals negative 4. Okay, either you know it or you don't know it, kids. Hopefully you can factor. An online company lets you download songs for 99 cents each. You have paid a $5 membership fee. Which domain would be the most appropriate to calculate the cost of download songs? Rational numbers greater than 0. Well, okay, so it's 99 cents. Those are rational numbers. Those are decimals. So yeah, rational numbers. The cost to download songs. I would not say it's whole numbers. An online company will let you download songs for 99 cents each after you have paid a $5 membership fee. Which domain would be the most appropriately to calculate the cost to download songs? Integers less than or equal to 0. That doesn't make any sense. Whole numbers less than or equal to 1. I don't know why you go less than or equal to 1. That doesn't make any sense. So we want rational numbers greater than 0 or whole numbers greater than or equal to 1. Which domain would be the most appropriate to calculate the cost to download songs? That really is an odd question. I'm not going to lie about that one. An online company lets you download songs for 99 cents each. Domain is the number of songs. The range is the cost. So the question says is what's the cost going to be? That's going to be a rational number. But the number of songs is going to be, well, 0 would be stupid. You're not going to buy any songs. So it's got to be 1 or more. And so the domain has to be whole numbers. So that was kind of a tricky question. Remember, this domain has to do with number of songs. And that would not be a rational number because you can't buy 0.8 of a song. So it has to be whole numbers. The rational number, which would be decimals, that would be the actual cost, and that would deal with the range. And in this case, it would be probably greater than or equal to 5 or greater than 5 or something like that. Okay, tricky question. Okay, this one's going to be a little funky. What we're going to do, let me write this one off to the side here a little bit. 3x squared plus 12x plus square, because I got to square, because I got to write in vertex form, plus 11 minus square. Because if I add a square, I got to take a square away. So I can't just add 2 squares. I got to take a square away, add a square, and take a square away. But before I can do that, I really got to get rid of that 3. So I'm going to take this 3 out, and I'm left with x squared plus 12x plus square plus 11 minus square. Now there's a trick to this nasty little question. We're going to do x plus 6 squared here. So in this one goes, oh, I apologize, children. I was just screwing something up. I took a 3 out of this. I took a 3 out of this, and I took a 3 out of this. So this should be 4. That should be 4. I apologize. So this is going to be x plus, and half of that is 2 squared. So 2 squared is 4. But I'm not going to put 4 here exactly, because what I actually added here was 3 times 4, which, so in this case, I got to add 3 times 4, which is 12. So the 3 is still here. 3x plus 2 squared, but then plus 11 minus 12, so that would be minus 1. So the actual answer is choice this. Now, having done it that way, which was the mathematical way, and if it was a part 2, I'd have to show that. But what I would do is, again, I like to use my calculator to help out. So I'm going to doc B this one, go back in here. I'm going to graph the original. Now, the original was 3x squared plus 12x. 3x squared plus 12x plus 11. Now, this isn't going to show up on your, oh, it is going to show up on your graph. Okay, it shows up. Now, if I did this correctly, this answer that I got over here on the right just better map right over it. So I'm going to tab, and I'm going to try to graph this one over it. So here's another problem that could have been done really with just the use of a calculator. Where the heck am I? X plus 2 and outside minus 1. Oh, and I forgot the squared. All right, enter. Bam! Mapped it right over. There I am. I'm good. I'm done. All right, let's keep going. A system of equations is given below. Which systems of equations does not have the same solution? Okay, so what they're doing is they're using the elimination method. So in this first one, how does these two differ from these two? The second one doesn't change, right? So what do they do to the first one? It looks like they multiplied by 3. 3, 6, and 15. 3, 6, and 15. So this one is the same. So let's take a look at the next one. What do they have that's different? Again, the second equation isn't changing, but it looks like they've taken the first one and multiplying by 4, by 4, and by 4. And that would be the same. Let's take a look again. The first equation's not changing, but they're multiplying the second equation by 3, it looks like, right? So this would multiply by 3 and get 6. This would multiply by 3 and get 3y. And this would multiply by 3 and get 12. Oops, that one looks good. So it looks like it's the last one. First equation's not changing. The last equation looks like they're multiplying by 2, right? Because 4x went from 2x, so this is 4x. This should be 2y, and this should be 8. Ah, there's the mistake right there. Bam. Tough question, but that's the elimination method. And you should have been very comfortable using that elimination method. I think we got 2 questions left. Let's see if we can get them done before my mouse starts not talking in line with my sound, which sometimes happens. Based on the graph below, which expression is a possible factorization of p of x? All right, so it's crossing at -3, so that gives me x plus 3. It's crossing at 2, so that positive 2, so that gives me x minus 2. And it's crossing at 4, so that gives me x minus 4. So that's what we're looking for. X plus 3, x minus 2, x minus 4. Now I only want 3 because it's an odd function. It's going up, and it's going up. And it only has 3 roots. So x plus 3, x minus 2, x minus 4, choice 1. That was 23. Yep. And finally, the last question. Milton has his money invested in a stock portfolio where X is the number of years since he made the investment. Which statement describes the rate of change for this value of this portfolio? Now, again, we talked about this earlier. This guy's getting robbed because here's his rate of change. It's 0.78. Now remember, if it's greater than 1, it's going up. If it's less than 1, it's exponential decay. Now, although he invested his money, he's losing money. Now, normally, this is like close to 80%. So if this was 0.8, he'd be losing 20%, but it's 0.78. So he's losing 22% per year. So he's losing 22. Now, in order for it to be increasing, that would have to be 1.78 or 1.22. In this case, it is 0.78, and because it's less than 1, my boy's losing money. He's got to get a new financial planner. Hit the subscribe button, hit the like button, comment if you have one. Let me know how you do. Let me know what you think. All right, kids. Bye. I got one more section to go. Actually, I got part 2, 3, and 4 to go. I'll be right back.